All right, so today with our solving our two variable equations, like we've got up here, we're also going to see the other variations to it. And we want to make the whole connection right back to graphing. Because what we're really looking at here is, for a solution, is we're looking for the x and the y coordinate where they equal each other. So if we were to graph those lines, the idea is they would cross somewhere. They would intersect with each other. And then we want to show what happens when they don't do such a thing. So let's take a look here. So going about our elimination. So hit that pause button. Let's see what you can do with it. Okay, so as I'm looking at this problem here, I'm noticing I've got a 4y and an 8y. I'm thinking, hey, let's multiply that 4 times the 2. It's already a negative, so that's perfect. So I'm just going to end up multiplying both sides by that particular 2, because when I can do that, then all of a sudden, hey, I'm going to have opposites. Remember, that's what the goal is. The goal is to get opposite numbers. And then that way, when you combine them, you get 0, they're eliminated. Because anytime you combine opposites, you can wave goodbye to them. So check out what we've got here. Now, you're not always going to get whole numbers. A lot of times you will, all right? And that's why that check set's important, because we want to see how the fractions work. So I've got x equals -1. Remember, we go back to the original equation. I'm just going to grab this one right here because I see positive numbers and the 3x minus 4y, but it makes no difference there. So if I plug in the 1, so that's 5 times 1 is 5. So 5 plus 8y equals -1. Let's subtract the 5 over. All right. 8y equals -6, and oh my goodness, we didn't get a fraction. All right, and that's quite all right. -6/8, that simplifies down to -3/4. So what we want to show you here is kind of how all this stuff is ended up kind of being related together. And what we want to be aware of is that because we got a solution, what that means is we were able to have a line and they intersected with each other. So if we just do kind of like a quick kind of sketch of what we've got going on here, we're going to graph our two equations. And again, we're not looking to get an exact answer because the graphing method, it's not ideal because, well, you have to use the grids and we don't have grids. And even if we do, they can land in between, like that -3/4, and we don't, based off of our picture, we're not going to know exactly that it landed on -3/4 that we're looking at. So yeah, let's take a look and see what we've got here. What we can do is rewrite it, which I think is kind of good practice for ourselves here. So 3x minus 4y equals -5. If I want to put this into slope-intercept form, ooh, pause it if you think you can do that there. I'm going to get that x, that y all by itself. All right. Whoops. So I'm going to subtract it over. So -4y equals -3x and then -5. And then I can divide everyone by a -4. Because remember, I want the y by itself. So that gives me a 3/4 x and then plus 5/4. So the idea here is I'm going to go up 1 1/4. So up 1 1/4. And then my slope is going to, so I'm going to rise 3. So up 1, 2, 3, and I'm going to run 4. 1, 2, 3, 4. Approximation, that's there. All right. So there's my one line, that's there. All right. Remember, my answer, all right, was at the -1, -3/4. So I can already kind of see, like, hey, -1, -3/4. It's looking pretty good. Let's grab the other one, the 5x plus 8y equals -1. The 5x plus 8y equals -1. All right, so the idea here is all right, let's subtract that 5x over. All right, so I've got 8y equals -5x minus 1. Divide everyone by 8. So I'm going to get y equals -5/8x and then -1/8. So again, we're not looking to get an exact answer here because we just know it's not going to happen. So if we go down to the -1/8, we're right there. And then the slope is negative 5/8, which means it goes to the left 5. So 1, 2, 3, 4, 5, go up to 8 that we're looking at. And maybe I've got something that's like that. Now, again, it's a rough sketch. I was hoping to get something right around -1, -3/4. I mean, it's not there, but it gives you an idea it's in the vicinity of it. Again, this is why the graphing one just isn't as effective. So we do want to be aware of it. Okay, so the other thing that we want to make sure that we are dealing with here is what happens in two kind of unique situations. And what we're going to end up seeing here is someone like this. 2x minus 6y equals, and let's go 12. And let's use 4x minus 12y equals 24. Okay, so in this particular, oh, you know what? Let's not make it 24. Let's make it 5. All right. So in this particular situation here, we're going to notice here is like, hey, let's, what can I do? Well, I can multiply everyone through by, no, not you. I don't want to multiply you because that's not going to work out. How about, let's multiply you by a -2. All right. And so when we do that, we get a -4x, a positive 12y, and then we get a -24. So when we end up combining them together, look what happens. Gone. And then, oops, hold on a second there. Positive 12y, -2 times a -6, yes. Also gone. So we've got nothing over here. We've got absolutely nothing. And then if we combine the 5 and the -24, that's -19. So because our variables are gone, is 0 the same as no, it's not. What we've actually got here is if we would graph it, is we would get parallel lines. So I'm just going to throw down an example of what we're seeing here. Because remember, the whole idea is where do the graphs cross at? And they don't here. All right, they don't. They have different y-intercepts, but they're going to have the same slope, and that means they never touch. Hey, so in this case, we call it a no solution because they never intersect with each other. All right. The other thing that can end up happening here is if we go back to the very similar problem that's there, and we're just going to jump right into it. What if we have 4x minus 12y equals, and then let's go after a 5, and then watch what happens if we get an 8x or a -8x. Let's go plus 24y, and then equals a -10. All right, so when we look at this particular variety, I know we kind of scrunched it in there, but watch what happens. If I multiply this through by a 2, all right, I'm going to get an 8x, combine it, gone. I'm going to get a -24, combine it, gone. I'm going to get a 10, all right, combine it, gone. So what I've got here is 0 equals 0. Now, you don't want to be like, well, wait a second, isn't that no solution? It's not. All right, when your variables disappear on you, one of two things can happen. No solution can appear, and that's because we ended up with a false statement. Is 0 the same as -19? No, it's not. So that's why it's no solution. Here the letters disappeared. Is 0 the same as 0? Yes, it is. So in this, what we call there is we say it has infinite solutions. And our little infinity symbol that's there. Infinite solutions. Because if we looked at these two graphs, they would actually be a line, and it'd be the exact same line right on top of it there. So that's kind of what's going on. Lines that intersect with each other, they cross some way there, you know, that's going to have one solution. Lines that are right on top of each other, well, they touch everywhere. So that's why we say infinite solutions. And lines that are just simply parallel to each other that never cross, well, that's going to be no solutions because, well, they never touch anywhere. All right, we'll see you later.